Welcome back. In this lecture, we're going to discuss color spaces. So far, we've only worked with RGB color spaces. That is to say, in RGB coding or red, green, blue coding, colors are modeled as a combination of red, green, and blue. However, RGB coding is actually a very old color coding. And in the 1970s, HSL, or hue, saturation, lightness, and HSV, hue, saturation, value, were new color models developed as alternatives to RGB. HSL and HSV are actually more closely aligned with the way human vision actually perceives color. While in the course, since we're just dealing with images, we deal almost exclusively with RGB images, or depending on how we open them, BGR, but the same rule applies, they're just combinations of red, green, and blue. However, even though we're mainly dealing with RGB images, it's a good idea to understand the very basics of how to convert to HSL and HSV color spaces. So let's quickly describe these color spaces, how they're different than RGB, and then we'll open up a notebook and briefly go over how you could convert an RGB image to an HSL or HSV color space. So as we already know, the RGB model is essentially going to represent a color as a combination of blue, red, and green, which we can describe this as a cube where we have some value of blue from 0 to 255, some value of red from 0 to 255, and then some value of green. And if we were to cut away from the cube, we can see there we have a value of kind of a tealish blue there, and we would say red is going to be 1/5. So that's not actually just 1/5 of the all values, it's actually 1/5 times 255. And then green, there's more green there, so it's 3/5 times 255. And then blue is 4/5 times 255. So we can see there just kind of how far along the scale of blue, red, and green we are for that particular color. So that's what we're already used to. Now let's move on to talk about HSL, and we can visualize this as a cylinder model. The way HSL works is we have hue, saturation, and lightness. And in HSV, we're going to have hue, saturation, and then value. So hue saturation, basically what this is all around the cylinder, there's going to be the actual different color. That is the green, the yellow, the red, what actual hue we're looking for. And then saturation is just how much of that hue do you end up having. And lightness is how dark or light it is. So we can see here on the top of this cylinder, all the values are actually pure white. They're all just as light, so the absolute lightness you can get is just pure white. And at the bottom of the cylinder, we have pure black, which is essentially no lightness in the color, regardless of its saturation or hue. This is similar to an HSV cylinder model, except instead of having a lightness, we have a value. So again, we have the hue color all around the circle, and then saturation is going to define how close we are to white versus how saturated we are in a particular hue. So notice now the top is basically the same hue all around, and we're just deciding on a particular value depending on the hue and saturation. And you may have played with some color pickers before that followed this sort of model, but notice now the white is actually at the very center of that cylinder. So essentially no saturation of any hue by default is then going to be white. Okay, so this lecture is just going to be a quick review on using the CVT color function to change color spaces. We won't actually have to deal with HSL or HSV based color images in the rest of the course, so this will just be a very brief lecture. We'll see you there. Okay, let's quickly show you how you could convert an image to HSV or HSL color space. All you need to do is say import CV2, and then if we want to actually display the results of these images, we can say import matplotlib.pyplot as PLT, and then we'll say matplotlib inline. Okay, let's choose any image we want. We'll just say CV2 image read, and in this case, I will go and upload or download the puppy. Let's go ahead and see that. We'll say PLT imshow and show that image, and there's our puppy. Notice right now it's in its default color space from OpenCV, which is blue, green, red. However, the image wasn't actually coded like that, so let's do a quick review. In order to fix this, all we need to say is image is equal to cv2.cvtcolor, pass in the image, and then say cv2 dot, and in all caps color, and then the coding that it's in right now, which is blue, green, red, and then say to the coding we want it in, red, green, blue. And if we display the image after that, we'll see that we get the nice puppy. All right, so what happens when we try to convert this to HSV or HSL? Well, it's actually a very similar process. All we need to do is copy this same code here, and we'll go from now. Remember, now we have it in RGB. And in fact, what we can do, if we want, we can reload the image. So we go from BGR, but we'll go from RGB, and then we can go to, and if we want to go to HSV, you can just start typing and you'll see HSV there. So if you show that image, it's going to look really strange because now it's in hue, saturation, and value. So it won't really make sense to display it this way because the color channels weren't modeled like that. But that is the way you would actually convert an image to be read in. And you could convert it from RGB to HSV. Or if you happen to be reading it originally with MRED, you could also do BGR to HSV. So lots of different options here. None of them make that much sense from HSV or HSL just because the original image wasn't coded that way. And as I mentioned, that was for HSV, hue, saturation, value. It's basically the same thing. If you want to go from a red, green, blue image to HS or HLS, excuse me, hue, lightness, saturation, you can do it this way as well. Run, and now you see the results there. Again, very strange, kind of weird, ugly results because the original image wasn't coded that way. Main thing you need to get in mind is there's various color spaces. If you ever need to do any sort of conversion, they're pretty much all here for you. You just say color underscore tab, and you'll see all the various options for you. Okay, so tons of options, and usually you only need them in certain specific cases. For the rest of the course, we're just going to be doing this blue, green, red to red, green, blue. All right, we'll see you at the next lecture.